Student page 89. Consider the compound inequality -5 is less than x is less than 4. Rewrite the inequality as a compound statement of inequality. So this compound x is greater than -5 and less than 4. So we know this is an and we'll start with that. And what we're going to do is we're going to say x is greater than -5. And we already have our and, x is less than 4. Write a sentence describing, so now we're going to describe the possible values. Well, if we think about it, what do we see? X is between -5 and 4. So we can say x is any real number between -5 and 4. Graph the solution set. Well, we have a less than and a less than with no equal signs. That means we need an open dot at -5 and at 4. And go ahead and we'll just fill in the values in between. Everything in between, right up to, but not including. That's why we have no solid dots. 3. Now we're going to consider the compound inequality. -5 is less than 2x plus 1, which is less than 4. If you notice, our two outside values match what we saw before, and the only change is happening in the middle. Rewrite this inequality as a compound statement of inequality. That means we're going to say 2x plus 1 is greater than -5, and because it's in between, we have an and, 2x plus 1 is less than 4. Solve each inequality for x. 2x plus 1, and then we have our -5. I have a plan here. I'm going to use some color changes, but I'm going to go ahead and set these both up. 2x plus 1, and if you notice, we have a plus 1 that we need to get out of our way. So let me make a 0 for a 0 pair. Look, there's my 0 pair. Whoop. 0, but since I subtract 1 from one side, I have to do it from the other. I'm going to go ahead and do that here and here as well. And we end up with 2x greater than -6. Divide by 2. And we find out that x is going to be greater than -3. Over here, another 0 pair. 2x is less than 3. Divide by 2. Sad, boo-hoo. Oh well, it's a fraction. We'll get over it. X is less than 3/2. So write the sentence describing the possible values. Well, our sentence has to be that, well, we want to describe when x is greater than -3 and less than 3/2. Those are the two values that, whoops, 3/2, not 4, so I'm just getting ahead of myself all the way around. 3/2. Let me find this. There we go. So what I'm trying to do is combine what I see here. X is greater than -3. X is greater than -3. X is less than 3/2. X is less than 3/2. So what I find is that x is between -3 and 3/2. All right, so we know we need -3, and then we encounter a problem. 3/2 isn't here. Well, let's see. 0 is 0 over 2. 1 is 2/2. That reduces to 1. If we want to reduce and get 2, we need 4 over 2. And now I'm hoping it'd be reasonably obvious to you where 3/2 is. 3/2 needs to be in between 2 and 4. So it's right here. We have an open dot. So we're going to open dot and fill in. Now, that's the end of that part of the lesson, but I want to share just a little something with you about how to solve something like, and let me go ahead and squiggle off a side here for us. We have -5 is less than 2x plus 1, which is less than 4. Now, we have 3 components to this, and in the past we've said whatever you do to one part, you do to another. Usually we say one side, you do to the other. But honestly, if I were to go ahead and say subtract 1 from here, wouldn't that match what we did right about here? And if I subtract 1 from here and 1 from here, I keep everything balanced. And notice how this starts to look a lot like the -6 we saw here. And now we have a 0 pair, so 2x, and we have 3. And now to isolate that x, all I need to do is divide by 2, 2, and 2. And you'll notice here we have a 1. And this one I can see that -6 divided by 2 is -3, less than x less than 3/2. Lo and behold, we have the same thing here. X is between -3 and 3/2. We have it here too. We've seen it everywhere. Yay!